Hello everybody and welcome to today's Syntacture webinar. My name is Göran and I will be the moderator for today's event. I'm glad to have Thorsten with me. As one of our cloud consultants, he'll share his knowledge about Azure infrastructure and Terraform today with us. So before we start, I'd like to introduce you to the user interface you can find here in the webinar application. To the right, you can find the chat, and well, you can leave us a hello there, and maybe from where you're attending. To the right view, there's a Q&A section where you can leave us questions you might have prepared or you run into during the webinar. Also, you can upvote questions of other attendees to bring them up in priority, so we can maybe have a priority list later. Because after the talk from Thorsten, we will have a look to your questions and try to find answers to them. Well, that was a quick introduction. Enough from my side so far. I'll hand over to Thorsten. So Thorsten, the stage is yours. Have fun and rock and roll. See you later.
Okay, great. Thank you. So also from my side, welcome and good morning, everybody. So let me quickly bring up my screen that we can have a look at the slides. So first of all, a small introduction about myself. So my name is Thorsten Hans. I work as a consultant with Syntacture. I mainly focus on cloud native application building and infrastructure as code, which is obviously the topic why all of you joined us today. So if you have any further questions after the webinar, don't hesitate, just ask. So you will find the email and Twitter handle and all that stuff also in the mail that we will send after the webinar. Okay, so I separated the talk in 4 main sections. So first we will look at what infrastructure as code actually is and what Terraform provides for you and why it is, I think, maybe a better option than other tools in that area. And so we will keep that short, and after that we will switch over to a live demo where we will create our sample Azure infrastructure using Terraform. So that's where we actually dive into all the nitty-gritty parts of Terraform and see how it works in real-world scenarios. Right after that, we will have a quick look at how to integrate Terraform in continuous integration workflows such as GitHub Actions in this example. And last but not least, I have compiled some useful resources that you can use to dive deeper into Terraform right after the webinar. Speaking about Terraform resources, I've also created and already published a cheat sheet on Terraform that is a small PDF that you can just print out and put it on your desk to memorize all the commands and stuff that you use in Terraform. And I think Göran already added the slide in notifications. So just click there and grab your copy of the cheat sheet. Okay, so let's jump into Terraform. So what is Terraform? Basically, Terraform is a product founded or created by a company called HashiCorp, and Terraform exists in different editions, let's say that way. So there is an open source edition that you can download and use for free, and that's exactly what we will talk about today, and that's what we in our projects use on daily basis. On top of that open source project, there are some enterprise add-ons or cloud features, let's call it that way. So you can opt in and start a subscription for Terraform Cloud, which basically adds some kind of collaboration features around the Terraform projects that you may create in your environment. And another edition of the Terraform Cloud brings in enterprise capabilities such as governance, to have fine granular about who is able to deploy infrastructures using a certain Terraform project and so on and so forth. But that's totally optional. I would say in 95% of the projects I'm facing, we don't use any kind of paid offering by HashiCorp. So you're good to go with the open source version. Speaking of open source, it's Terraform. It has been written in Golang, so the Go programming language initially founded at Google, and that leads to Terraform being a small distributable that you can just download and run it on almost any kind of operating system. So it's really handy and it's easy to distribute to a continuous integration system. So it's just a single binary. You download it. You ensure that the user account is able to execute the binary, and then you're good to go. So that's a little bit about Terraform and what it is. And basically, Terraform addresses infrastructure as code capabilities. So in Terraform, we always talk about three main pillars of infrastructure as code. So first, obviously, we have to adopt infrastructure as code. We will look into that first. And once you've made your way through those infrastructure as code adoption, Terraform allows you to preview changes before applying them. And third is we can build reproducible infrastructures using a single Terraform project. So if we dive into infrastructure as code, basically it means that we as application developers or as DevOps people should ensure that all the servers and services required to run our application are described in code. This brings some advantages because if you have your infrastructure written down in code, you can put it in version control systems such as Git. And Git, especially when using systems like GitHub or Azure DevOps, you can bring in collaboration features and you can do a pull request workflow to ensure that modifications on the infrastructure are checked, verified, are reviewed, and are documented. So this is a huge benefit if you think about the journey of infrastructure, right? So if I remember a couple of years back, there was that one guy in the company who was responsible for spinning up the web servers. The other team was responsible for keeping database clusters alive, and so on and so forth. By using tools like Terraform or other infrastructure as code competitors, we can create a shared knowledge about the infrastructure. So, for example, the memory associated with web server is no longer just an input field in a portal like Azure Portal. It's now a regular property on a first citizen resource in your code base. So if you, for example, over time change the memory associated with your web server and bad things happen, so the web app doesn't perform as expected, you can quickly go to your Git repository and double check the modifications in the previous comments, right? So it makes everything a little bit more documented and transparent. Additionally, we get rid of the drag factor, right? So there is no more, there is not that single person who's having the knowledge in his or in her brain. So everyone can read and, contribute to the infrastructure. Previewing changes before applying. So the second stage or the second pillar of Terraform, that's what I think is the USP, so the unique selling point of Terraform compared to other competitors. So in Terraform, you describe your state in code, and at some point you want to modify existing infrastructures, or you want to create a new infrastructure. And what Terraform does at that point in time, it investigates. So it takes a look at the targeting cloud or private cloud or infrastructure environment, and it creates a diff. And you can think of that as a git status, right? You have some changes made in your Terraform project locally, and then you execute or then you instruct Terraform to check against the production or development environment, and it will bring up a list and will say, hey, according to your changes, I have to create a new database server. I have to modify those properties on your web server. And previously you had, let's say, this caching engine running in your infrastructure, but it has been removed from your code file. So I will remove it from the cloud or from the private cloud infrastructure. So, and this is really important because you don't actually modify any kind of service or any kind of server in your target environment. You just seeing what would happen if you apply those changes to the infrastructure. And this makes, infrastructure or coding infrastructure fun and a really smooth process. And third, obviously, we can build reproducible infrastructure. We can do so because in Terraform, Terraform uses a declarative language. So we describe the desired state of our infrastructure. And we can bring in certain, let's say, contextual information to differentiate between, let's say, the development, the staging, and the production environment. But key takeaway here is that you always describe the desired state. So Terraform's job is just to talk to underlying cloud infrastructure or cloud vendor APIs and do everything that's required to have the final infrastructure be a representation of the state you described. So no matter what it takes in Azure or on AWS and so on, to bring up your desired state, Terraform will take care of it. Okay, so speaking about Terraform projects, every Terraform project runs through the so-called Terraform lifecycle. And the Terraform lifecycle is really straightforward. We start writing some code that describes the desired state of our infrastructure. Then we execute, or we use Terraform CLI to execute Terraform Plan, which gives us this preview, right? This execution plan. So what will happen if we apply this code to the target infrastructure vendor? We verify that plan, and at some point we say, yep, Terraform, that looks good. Please go ahead and create or modify the infrastructure. And then, or to do so, we invoke Terraform Apply. And Terraform Apply will actually talk to the cloud vendors' APIs and spin up all the resources that we need. Then we can consume the infrastructure, and we finally made our way through the lifecycle once, and then we can iterate over that lifecycle again and again. So we can do some modifications, preview them, verify them, apply them, consume them, and so on. And maybe at some point you don't need the infrastructure anymore, then you can just call Terraform destroy and provide a contextual information, of course, again, approve it, and then Terraform can delete all the services and servers in the cloud infrastructure. And to do so to describe or to actually start building infrastructure as code with Terraform, Terraform uses the HashiCorp configuration language, or HCL, how it's also referred to. That's just a superset of JSON, which you will see it in a couple of minutes. We will get rid of some of the syntactical requirements that JSON have, so it's more focused and it's easier to read for both human beings and machines, and it's easier to understand what's going on. Terraform or HCL introduces some basic types like strings, numbers, maps, and so on and so forth that we use to bring in contextual information into our projects and to, don't repeat ourselves. And the best thing about Terraform is you learn HCL and Terraform, and you've already learned the majority of things about Terraform in the past 10 minutes. So you learn it once, and you can reuse the knowledge no matter which infrastructure or cloud vendor you're actually using. So it doesn't matter if you're using Azure, AWS, Google, GCP, whatever, or if you're running in a private data center and they use some kind of VMware infrastructure abstraction layer, you can talk to it. And to do so, Terraform uses so-called providers. So for the upcoming, let's say, 30 minutes or so, we will take a look at terraforming Microsoft Azure using the Azure Provider. And as previously mentioned, it really doesn't matter what you're targeting. If you're targeting Azure or AWS, it's pretty much the same. But at this point, Göran, can you fire up the poll, please? It would be interesting to see what you guys actually using as cloud infrastructure or which vendor you're relying on. So please, vote for the poll, and we will cycle back on that one at the end of the webinar. Okay, so back here, let's jump into terraforming Azure. As for every other cloud vendor, Terraform offers an Azure provider. A provider is just a set of, like a proxy for Azure's ARM API. So behind the scenes, Terraform talks to Microsoft's official ARM API and instruct Azure to, spin up a server, modify a database, whatever. And this also slightly defines the scope, what's possible in Terraform, right? So you can do everything in Terraform that's offered via ARM APIs. That said, not everything that you can do in the portal is available via ARM API. And if you're already using Azure, and for example you're using Azure CLI, you may have also noticed this limitation, because there are certain features, especially in previous stages of products, where Microsoft brings the portal experience first, and if customers use the new feature or they see an adoption for that, then they will bring in ARM APIs, or will make those underlying APIs public through Azure ARM. So we will use that in a minute. And there are different authentication patterns that we can use. First and simplest one is reuse existing authentication that has been established via Azure CLI. So that's great for developer experience, right, to get started. So Terraform will act or interact with Azure's APIs in behalf of your user. But if you go beyond getting started, you will want to use a dedicated service principal. So you can just go to Azure Active Directory or use Azure CLI to create a new service principal, and then use that as authentication mechanism. We will use that also for the continuous integration and GitHub Actions later. Third is we can use a managed service identity. So if you're executing your Terraform scripts on an Azure resource that supports managed service identities, then you can execute the Terraform script in the context of that MSI. So those are the three main authentication protocols or patterns that are supported. Okay, so the provider, as mentioned in the slides, gives us read and write access to Azure resources. So let's get rid of PowerPoint at that point in time and switch to not the Azure portal. Let's bring up the other instance. So I've already created a public GitHub repo, and we will share the link to the demo later. But basically go to GitHub, Think Texture, and there you find Terraform webinar, December 2020. And so there's nothing in there yet. There's a git ignore that is just ignoring all the Terraform things that should not go to source control. There's a license. There's a README that guides you through the process. And there are 2 empty files, right? There's a main.tf, there is a meter.tf, but they're still empty. And there is the GitHub action, which we will look at later. So a Terraform project, or every folder, is a valid Terraform project by definition. So Terraform has no, project file or stuff like that. If you are in a folder and you create a bunch of .tf files, that's enough for Terraform. And that also implies that there is no fixed structure or no fixed way on how to organize your project. So I tend to, separate different kinds of services and to keep things organized by myself. I have already installed Terraform CLI, so I went to terraform.io. Let me quickly bring up the website, terraform.io. There we go, and there we can, you can just download the CLI for the operating system of your choice. Once you have installed that, you will find a Terraform executable. So I have installed version 0.13.5. That's great to get started, but one thing you could take a look at after the webinar is Terraform Version Manager. That's called tfenv, which allows you to quickly switch between different Terraform versions on your local machine, and also to download or uninstall older or newer versions. So that's what I'm using behind the scenes. Okay, so we have Terraform installed on our system, on our machine. We validated that with Terraform version. And let's quickly jump into Visual Studio Code. So if we want to automate Azure infrastructure, or if we want to automate Azure with Terraform, we have to bring in the Azure Provider that I previously mentioned. To do so, we bring in a provider resource and say Azure AD, not Azure AD, Azure RM. And let's say we want to use the basic feature. So that's a configuration requirement for the Azure RM provider. And let's save that. And if you're curious about what I'm using Visual Studio Code. And I have installed the Terraform, the official Terraform. Quickly rearrange that, and by looking at the icons, it makes it easier to spot the extensions. So I've installed HashiCorp Terraform in the most recent version, and I have installed a community extension that's called, because it's very handy, Terraform Documentation Links Plus in version 001. This is a simple extension, right? It's again here the author that it's a dump extension, but I find it very useful, and you will see it in a minute. So that's what I've installed to get syntax highlighting and everything up and running. Okay, so we have the Azure Provider installed, and we are already good to go. So that's our project setup, right? We tell Terraform, hey Terraform, I want to talk to Azure. Then we go to our terminal, and I'm in the scope of that project, right? So if I do a cat meter.tf, there is provider Azure RM, and then I say Terraform in it. So that's then an instruction that says when Terraform looks at those provider types and installs all the providers I mentioned. And as we can see, Azure RM gets installed, and I'm good to go. Okay. If you want to write or create new resources in Azure, then we use an object of type resource. So resource always means I want to write, modify something in the target cloud environment. And in Azure, everything starts with a resource group. So let me create an Azure RM resource group. And let's give it a key. The key is used in our project to reference that resource group. So the key will at no point appear in Azure. That's just for the project itself. And every Azure resource, like the resource group, requires some kind of metadata, right? A resource group in Azure obviously needs a name, and we call that RG as prefix, Terraform-webinar-December 2020. And we have to instruct Azure in which region that resource group should be created. And let's use West Europe for now. And there are obviously additional attributes that we can or have to set. And that dump extension, as the author mentioned in the README, allows me to hold the command key and press on a type and immediately jump into the Terraform documentation and see, okay, a resource group in Azure consists of at least the name and the location, because those are required. And we can bring in tags. So you may know tags, so like post-its on Azure resources to group and govern certain things. Okay, great. So that's why we have to install that dump in quotes exception. Okay, great. So that's already a valid infrastructure, right? So let's put that over there and perhaps take the terminal over here. And let's rearrange that a bit. I'll get rid of that. Okay, so let's say Terraform Plan, because we want to preview what would happen if we apply those changes to Azure. So we see Terraform somehow refreshing state from Azure, and it says, okay, there in your state, you describe a resource group that I'm not aware of, and I will create it in West Europe. The ID will be assigned by Azure, so that's not known at that point in time. And it will end up with having a name of RG Terraform Webinar December 2020. Okay, so that's how you write resources in Azure. But if we think about, let's bring in, for example, an Azure RM, let's say application insights. Let's start with that one because it's easy. We bring in a name and let's say it, that's AI for our web app. And we have to deploy that one to a certain resource by bringing in the resource group name. So we can repeat ourselves and say Terraform webinar December 2021, and then I made a mistake and it won't reference the resource group anymore, right? So we can bring in, or we can use values that we have assigned once by referencing other resources. So we reference the resource group with the name RG, and from there we pull the name. Same can we use for the location. Obviously, we can say West Europe or West US or East US or whatever region, or we can just say, hey, just grab the location I specified on the resource group in the location key. Okay, so this would lead to Terraform Plan saying that it will add, oops, there's a missing required argument. Okay, the application type. That's right. Let's bring in the application type and set it to web. The order of the attributes doesn't matter, just as a quick hint at that point. So let's plan again, and we will see that it will try, or it predicts that it will spin up 2 resources in Azure, right? Come on, there we go. It will add 2 resources, the resource group and application insights. Terraform does implicit dependency tracking. So Terraform looks at all the resources and it recognizes that application insights relies on the resource group. And it will also find that dependency if you repeat yourself. So it's not because of referencing it over here. It creates a dependency tree when executing Terraform Plan, and tries to parallelize as much as possible to be as fast as possible when it comes to deploying infrastructures. So, and that's why it's inversed, or why it's descending order, right? So at last, it will create the application insights instance, and the first item that will be created is on the bottom. That's the resource group. Okay, so we could spin up that one, but yeah, maybe tomorrow I will want to spin up in North Europe. So let's bring in a new file over here, and let's call that variables.tf. That everything can go to a single Terraform file if you want to get started, but I want to, keep things separated and have some structure on organization over there. So we can bring in variables in Terraform, and let's say location. And the location is of type string, and it has a default value of West Europe. And we can add a description and say where should Azure resources be created or located. So put it that way. Let's remove the default value for now, and let's use the variable. So we just get rid of the magic string over here and say location. Use the location variable at this point. Okay, so we use the variable in resource group, and from that point in time, either we reference the resource group, or we can also tie that one to the variable. Great. So we have not specified any value for location at this point in time. If we execute Terraform Plan right now, it recognizes that this variable has no value assigned, and I can bring in East US 2, I guess, is a valid value for an Azure region. And it will again look at the Azure environment, and it will say, I will create a resource group in East US 2 and an application insights instance in East US 2. Okay, so but that's not that handy for execution and unattended execution like on a continuous integration system. So we can say Terraform Plan dash, or let's bring up the help that gives you an idea of what's possible. So we can either specify the variable directly as part of the command, but it may leak some sensitive information. So we can bring in a variable file from somewhere that we can just, for example, create here in our repo, or we can create, or we can set environment variables that follow tf var underscore variable name location. So then we can, for example, use things like GitHub secrets or secrets in Azure DevOps to bring in sensitive information instead of putting it in the terminal and leaking it in the terminal history, for example. But for now, let's say we want to execute Terraform Plan and pass variable location equals North Europe. Right now, Terraform recognizes that the variable has a value assigned, and it will just bring up the execution plan and will try to spin, or it would spin up those resources in North Europe. Okay, great. So that about variables. And because we're here, let's bring in a new one. Let's say custom tags. And tags in Azure or in Terraform are of kind map, and the default is an empty map. And description is custom tags associated to every resource, Azure resource. Okay. The idea is that we can, provide tags like post-its that will be attached to every resource or by setting a variable in the command line interface or by using a variable file. But at some point, you may want to govern a little bit more. You may want to bring in a default set of tags, and that leads to Terraform expressions or functions and local variables. So we can define locals like default tags. So tags the default tags for our project. So for example, it's responsible is Thorsten Hans, and kind is webinar resources. Okay, but how can we bring in the custom tags? We can define another local variable. Local variables are available in the scope of the entire project, and say all tags equals true. And then we can use the merge function and say, take the default tags, local.default _ tags, and merge all values from variable custom tags into that. That means if I add a third tag, then the final list will consist of 3 tags. If I re-specify responsible, then I will override the value. So it's flexible and can be, customized depending on the actual need. And then I just have to bring in local.all _ tags over here, and let's put it over there too. And let's verify that one. Execute Terraform Plan. Specify the default value. Yeah, okay. So let's say Terraform Plan. It's refreshing the state. Obviously, it's not able to find anything in the cloud. And we will end up with having 2 tags assigned to both resources over here and over there. Great. So up until now, we have not modified any cloud resources. So we have just, planned, or we just looked at the execution plan and tried to understand what will happen. So let's clean up this one, and let's go to meta.tf again. Modifying existing infrastructures may lead to concurrency issues. If you think about you and your coworker trying to modify the same service in Azure, in AWS at the same point in time, Terraform somehow has to, deal with that and to ensure that infrastructure resists in a consistent state. And to do so, Terraform tracks the state of the cloud environment. And there is a so-called state file. So the state file is a versioned JSON representation of your cloud infrastructure. And this works for a single developer experience that works with running or using local state. That's how the default configuration is referred to. But in a distributed environment where, for example, GitHub Actions will also modify the infrastructure, this won't work anymore. So Terraform knows something that's called state backends. And state backends are basically some kind of storage system that supports locking, like active locking or resource locking. And luckily, there is AWS S3, there is a dedicated offering by HashiCorp in Terraform Cloud, and there's support for Azure storage accounts. And we can configure state backends by using the backend Azure RM block. So over here, we have to bring in certain configuration variables. So let's say our state backend resource group name resists in a resource group that's called dev.thh. So that's my personal resource group, and we will look at that in a minute. And we have to bring in the storage account name equals to that, and we have to bring in the container name over here. I think it's container name. Let me quickly check. Yes, and we bring in a key, and we bring in an environment. So the environment says or tells Terraform that we are talking to Azure Public Cloud, Azure Governance Cloud, whatever. So that's public cloud, and the key is basically a segment of the file name that Terraform will create in the Azure storage account. Here it is Terraform TF state, and we will call it webinar.tf state. And the container name is a folder in Azure Blob Storage. We call that TF webinar. So we need a storage account. Okay, let's bring up the Azure portal. There it was. There it is. There's the resource group. Go into the resource group, several resources over here, but we will look at this one, the storage account. We grab the storage account name. Let's quickly verify TF webinar. That's the folder, and the folder is empty, right? There are no blobs in that folder yet. Let's paste that one in. Okay. So we have configured everything for the state backend, but somehow we have to authenticate Terraform to talk to the state backend. And to do so, you have to set an environment variable that's called arm access _ key, and you set it to a value, from your storage account. You can grab the access keys. I won't show the keys right now, but just copy that one and set it as an environment variable. You can do that on Mac, for example, in the terminal for the current session using export equals my key, blah, 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 something, and you're good to go. Okay, so I've created that already. So let's do a Terraform plan with having the backend configuration, but I think we have to re-init it. Yeah. Terraform Plan will tell. So maybe that, yeah, it falls apart. Okay, so Terraform recognized, hey, there is a new state backend. Please re-init the project. Okay, let's re-init it. And it checks, okay, the newly configured, do you want to copy this then? Oh, start with a new empty state. So I don't want to upload the existing state file because we haven't applied the infrastructure yet. So Terraform will create a new storage, a new blob in the storage account. Let's verify that one. There we are, webinar TF state. And as you can see, let me bring in that one. You see there is locking support in Azure, but it's not locked at this point in time. Terraform just locks the file when we start a write operation. So when we start to modify the infrastructure. And once it's done, it releases the leak again. Okay. So we have the state in place. Let's apply it. Terraform apply. Terraform apply will again execute Terraform plan. We can prevent that by adding an argument to the call. And now it asks, hey, does it look good for you? And if you say yes, then it starts automating Azure. So it creates the resource group, creation completed after a second. It's creating the application insights instance, and depending on the service, it may take a couple of seconds. And there we go. Apply complete, 2 resources created. Okay, I have to slow down a bit because Azure Portal requires some time to see new resources. Let's query for webinar. It's not there yet. It's not there yet. There it is. So it needs the UI needs just some time to find all the resources in the Azure Forest. And there is our application insights instance. And if I pull down more, then you see those are the custom tags associated with the resource, and I can drill into the application insights instance, and we're good to go. Okay, but how can we create multiple infrastructures? So, for example, we can use something called Terraform workspaces. Let me ask Terraform for all the workspaces. And by default, we are looking at the default workspace. Surprising, right? So we can bring in new workspaces. Let's say Terraform workspace. I think it's new. Let's create dev. New. Okay, it's new. Terraform workspace new with the name dev. Okay. So if I pull again or ask again for all the workspaces, we will see that right now we're pointing at the dev, and my terminal also is able to show that information over here. But yeah, that would lead to name conflicts, right? Because the resource group has no environment-specific part, and the application insights instance also has a fixed or hard-coded name. So we can bring in the current workspace name by using interpolation and say Terraform workspace over here, and let's bring it in over there too. Okay. And let's say Terraform. Let me quickly show two things. So we can ensure that the Terraform script is formatted correctly using Terraform format that will reformat everything. And we can do validate to ensure consistency in our script or in our project. And once we've that done, that's a regular workflow, right? So the more fine granular workflow. Then we plan it again. It looks at the Terraform. It looks at the Azure cloud, and it says, okay, I have to create 2 new resources because I don't know this resource group, and I don't know that application insights instance either. So I can say Terraform apply, but right now let's provide auto approve, and it will automatically start provisioning both the resource group and the application insights instance. So resource group is already done, and application insights takes a couple of seconds. And using Terraform workspaces allows you to spin up multiple environments in no time, and every environment is managed independently from the others. So we will verify that in a second. Let's say, okay, Terraform workspace, create new staging, and we create the workspace. It automatically switches to staging, and we say just invoke Terraform apply auto approve. And let's revisit our storage account. So the state backend, because state backends are mission critical in Terraform, right? Let's query for my personal resource group. Okay, filtering a list in Azure takes some time. What the heck? Let's refresh the portal. Okay, so there are the resource groups. Let's bring in mine. We see that's a storage account. Let's go to containers. Let's dive into the webinar container. And now we see a state file per workspace. So they are managed independently from each other. And if we now go to resources and again search for webinar, we will see that we have 3 independent resource groups with our Azure infrastructure, which is obviously, you know, for demonstration purpose, just an application insights instance. Let me quickly show you another top-level building block that's so-called outputs. Outputs are a way to use to query for information that has been created as part of the Terraform project. So we can create a new output and let's say instrumentation key, because that's the critical thing, right? To use application insights, we have to use its instrumentation key. So we can say Azure RM application insights. How's it called? AI, I think. Instrumentation key. There we go. Intelligence. Took a while. Okay, let's quickly. How did I know that it's called instrumentation key? Well, if we bring up the documentation for the application insights resource, oops, wrong screen, then you can always scroll down and see that's what you can configure. And the attribute reference is that what you can query for. And there's the instrumentation key. Okay, so that's specified over here in the outputs. Outputs is pointing to application insights AI. Application insights AI. Let's Terraform by auto approve. Now it looks at the cloud and it recognizes, okay, there are no changes that I have to make besides just querying. No edit, no changed, no destroyed, but I have to query the instrumentation key and it prints that out. So I can use Terraform CLI. There are several subcommands, like for example, output. Read an output value from the state file. So I don't have to apply in order to read that output. I can say Terraform output and the name is instrumentation key, and lazy me, let me quickly bring that in and I can ask for that one. That's cool, but sometimes you don't want to leak sensitive information, so you can say sensitive equals true. And if I do Terraform Plan once again, let me Terraform apply dash auto approve. And then we will see that the value will be masked in the terminal. Cool. So let's quickly wait for that one to be printed over there. There we are. And we see it's a sensitive value, so it's not leaking any kind of sensitive information over here. So let's jump back to PowerPoint and have a look at continuous integration. So there are official actions or activities or tasks provided by HashiCorp to bring in Terraform into your GitHub actions. And in combination with GitHub secrets or repository secrets, you can securely enable connectivity to Azure. So let me do one thing first, because of reasons. Let me quickly get commit sure live demo. Let me quickly commit. Oops, makes sense. Quickly commit and push. And push it. So I pushed it to GitHub, and let's move over to GitHub for now. And let's have a look at the repository settings. And now you can see secrets. and I set the access key to my state backend, or to the storage account that I use as state backend. I set the client ID, so I've created a service principal for authentication, and I provided it with its ID, the password or client secret. I tie or I target to a specific Azure subscription. That's the one we saw on the portal earlier. And I provide the tenant ID so that the Azure Arm API knows in which Azure tenant it should look for the service principal to authenticate. Okay, let's quickly go to, nope, before it falls apart, I know why. Let's quickly look at the workflow. So the workflow checks out the code. It uses the official HashiCorp action to set up Terraform. It installs the version that I'm using locally. It executes Terraform init. It provides sensitive information just for that commands like Terraform init or plan or apply that require sensitive information. So I don't want to leak the client ID, for example, to Terraform format, because that doesn't need to know which security context I'm running in. Then I execute plan, and if it is a push on the main branch, then I execute apply with auto approve, and no color makes the output in CI or in actions look nice. So let's go and check why it doesn't work as expected, and we see Terraform format. Okay, I've pushed code that's not properly formatted. Lazy me. So let's say Terraform format, and formatting, or Terraform FMT, sorry. FMT does modify the source files. And as you can see over here in GitHub Actions, I execute Terraform FMT-check, basically tells, hey, this file is not valid, and it has a non-zero exit code. That's why the GitHub action broke. So I reformatted, and I see there's an outstanding change. I committed. Format correctly. Oh, I haven't edited. Sorry. Git add, git commit, fix format correctly, and let's push that to GitHub. There we go, and we should see a new action being fired up in a second. There we go. Okay, so we wait for GitHub to assign a container. Container is assigned. It inits Terraform. It formats. It checks the format. Looks good. Now it plans like we did before on our local system. Okay, it recognized there's something. Oops. Let me quickly bring up those logs again. So there's something that it has to change. It has to, because we're running on a default workspace, I haven't used Terraform Workspace in CI yet, so it will spin up a new webinar resource group and a new application insights instance with the default workspace as suffix. Okay, so there's room for improvement for my CI pipeline. What you normally do is for example, you have branches matching your environments, or some kind of combination or link between the branch and the workspace, and then you, for example, in a pull request, you will just watch or just plan in the context of the correct workspace. So, for example, if a coworker asks or creates a pull request pointing on main, I would use Terraform Workspace select production, and I would ask Terraform Plan to verify what would happen to the production environment if apply executes. And while Azure or GitHub is modifying Azure at this point in time. Let me bring up the workflow file again, and let's show this one. So there's a condition, Terraform Plan apply, only executed on the main branch and only if it is a push. So if someone creates a pull request, it will just plan, it won't modify. And that's typical, typical pattern for CI and CD in Terraform. It still takes some time to modify. There we go. Apply completed. And finally, let's move back to the Azure portal. Go to resource group and refresh. Come on. Take a couple of seconds, but finally we should end up with a default resource group over here. There we go. And there is our application insights instance created also by the GitHub action. Cool. So that was almost everything from live demo perspective that I've prepared. Last but not least, I have a couple of resources. So if you want to dive deeper into Terraform, then just grab the slides after the webinar, and there are certain links that you can follow and dive deeper and learn more. But Göran, what was the outcome of the poll? What are people using? Are they using just Azure, or are there also people using AWS and GCP? Okay, somehow Göran seems we lost him. Quickly check. Okay. Okay, so let me quickly look at the polls. So what we have Azure with 70%. We have Google Cloud Platform GCP with 5%, AWS with 11%, and private data center with 5%. For the AWS folks of you, the Terraform book Up and Running is focusing AWS, but in the end, it doesn't matter. Just learn the Terraform lifecycle, learn Terraform Provider, learn HCL, and then the provider documentation is pretty good for every provider that's available. And it doesn't end with, the major cloud offerings. It goes beyond that. So you can, for example, create all your GitHub repos and stuff like that using Terraform. And I think Göran is back again, right? Okay, because I didn't hear anything from you. And there are you. So there's your picture too. So do we have questions? Do we get questions during the webinar?
Yep, sure. We got 2 questions.
Okay.
I suggest to start with the one with the most votes. So Sebastian is asking, can I start using Terraform in an existing Azure infrastructure without affecting it?
Good question. So that's a question I face quite often. So you can import existing infrastructure into Terraform, and any kind of existing infrastructure. It isn't limited to Azure. There are several open source projects. I think Terraformer is one called that may assist in that process. Because what you basically use, there is a command called Terraform import, and Terraform import can so you create an empty skeleton, just resource type, and a key, and you ask Terraform to import a given Azure resource by pointing to the resource identifier. That means that you have to repeat that for every single resource, and you have to manually take the output from Terraform import and add it to your source control. Another way of importing is you can export an Azure ARM template from the Azure portal and use that as a resource. But then modifications are a little bit limited afterwards. So I would suggest looking at Terraform import for smaller projects, and for real world projects or real world infrastructure, bigger infrastructures, I would take a look at those open source projects like Terraformer, if I remember correctly, is it called? They may assist you or make the process of importing resources less error prone or less tedious. Okay.
Okay, thanks, Thorsten. So,
second question.
Just let me say something. And
okay.
It's not only for Sebastian; it's for everybody in the webinar. If you got questions afterwards, or you need more information about some answers or whatever, feel free to reach out for Thorsten or for me to get in touch with us, and yeah, let's talk about the questions or the more information that would be needed. So, well, let's proceed to the next question. Detlef sent us one question, not some. Are there any advantages in using Terraform compared to using Azure Resource Manager templates if you are only going to deploy to Azure?
Yes, good question. That's always asked by folks using Azure and having walked through the pain of using Azure ARM. So first of all, Terraform is way more compressed than Azure ARM. So it's not that chatty. You don't have to write hundreds of lines of JSON, right? Second, and most important part is obviously Terraform Plan. So the execution plan and fine granular, tracking of what's actually deployed in Azure compared to what you describe in your file, that's the most prominent difference. And personally, for me, I think having concepts like Terraform workspaces and implicit dependency tracking, or Terraform modules that I've also mentioned in the resources that you can dive in later. Modules allow you to build reusable components, right? Like Azure App Service looks that way, but in your environment, in Azure App Service always have those default configuration values. So you can create that once, create a module. Module is again nothing else than a folder, and then you can reuse it in all your projects and govern over the infrastructure projects. And you can pull those modules from GitHub, from official registry, from a file share, from everywhere, right? So those are the most prominent benefits. And compared to Microsoft's currently working on something that's called Azure, or yes, I think it's called Azure Project Bicep, which is basically also addressing infrastructure as code in the scope of Azure. But for what I've seen up until now, Project Bicep is also chattier than Terraform, so you have to write more to achieve the same. So those were the aspects that I was looking for.
Okay.
Yeah, but Detlef, if you have further questions or want to discuss about that, just reach out. I mean, that's always an interesting topic to see where folks is struggling in adopting Terraform, especially in contrast to ARM.
Okay, let's proceed.
Cool.
Okay, another question from Sebastian.
Yeah.
How to use outputs like the application insights instrumentation key when creating another resource like a web app using Terraform?
Good question. So the output is not meant to be used in the same project. The output is meant to use, for example, if you create a module, like I mentioned earlier, like a reusable component, then you use those outputs, right? So outputs are the API, the outbound API of your Terraform project. And for example, in GitHub, I would perhaps require or want to reuse that instrumentation key to connect to it using Microsoft's Application Insights action and create an annotation in Application Insights that I can see in the application logs. Okay, there was an infrastructure modification. In the scope of the project, you can just reference from your web application. You can just reference the Application Insights instance and say, Azure RM _ application _ insights .ai, that's the key of the resource, .instrumentation key, and it will automatically inject the instrumentation key to your web app, like we did for resource group name. So that's how you link together the resources in your project. Yep.
Oh, okay. Thanks. So let's proceed to the latest question sent in. So we will start from below. Ren, wants to know something. I just read it down.
Yeah.
Can I also use Terraform with Azure Stack on premises? And if so, are there any restriction in functionality?
Oh, that's a good question. Haven't targeted Azure Stack up until now with Terraform. That's definitely something I can look into because it's interesting. Perhaps just shoot me a mail. Shoot me a mail, then I can look into that, and then we can follow up. I was using it with Hyper-V. So there is a community Hyper-V provider that you can use to target to on-premise infrastructure managed by Hyper-V. But regarding Azure Stack, I mean, there is obviously that switch, that toggle to specify the environment for Azure, and maybe that's the right direction, but I'm not sure about the Azure RM provider. So I would love to dive into that, and we can talk about that afterwards. So just shoot me a mail, and we can look into that and then come up with something.
Yeah. After the webinar, it just gives some hours or maybe days at the moment. Everybody will receive an email from us with the link for the recording of the webinar, links to GitHub and so on, and the slides, so you can find the contact information there too. So no need to have them noted, written down now. Okay, Thorsten.
It's just first name dot last name at thinktexture.com. So
no rocket science, but I thought it would be worth mentioning it.
Yeah. Okay,
so let's have a look into the last question sent in by Felix.
Yeah.
It's a little bit more text, so I suggest you to read it.
Okay.
So I read it out loud, but you should read it.
Okay, cool. Yeah, go ahead.
Okay. Imagine we've got 20 app service resources. Each of those is using a custom module resource to ensure each app service resource is configured in the same way. Now at some other place, we need to work with the outputs for each app service. For example, FQDN, to do something with it. As far as I understood, Terraform enforces inversion of control by design. For example, in our custom app service module will not be able to access a variable above it, like a list, or add itself into it, right? That means that we right now need a central place in our Terraform configuration where we manually manage a list of all app services that we know of. This is error-prone and kind of annoying. Do you know of a way how to achieve something like an app service module registering itself in some kind of Terraform list automatically just by using this custom module?
Okay, good question. So I was facing similar issues in almost every project. So what Felix basically described is that module is like think of it like a subfolder, and modules also have inbound and outbound APIs. So inbound APIs are variables that we have learned about today, and outputs are outbound APIs. So we can, for example, grab the FQDN, so the blah blah blah.azurewebsites.net URL, and use it within the context of another resource. And with recent releases of Terraform, I think it was released with version 0.13, you can create modules as part of dynamic blocks. So dynamics are a kind of advanced usage pattern in Terraform, or at least it went beyond the scope of that webinar. So basically, you can create a variable with all the, let's say, prefixes or subdomain names that you want to spin up apps or the app service. Like think of API, app, login, reports, whatever. So ending up with 10 app services instances, and then you can use a dynamic block to iterate over that list, over your variable, and create app module instance or module instances. And the module instance, again, will, be configured using input variables. Querying for the output variables requires referencing the module by key. So that requires, for example, if you have an API and reports module, then you have to say my module dot, and then you have to provide API to access the API instance behind that module to ask for the output. Typical scenario where you have something like that is when you create a bunch of app services and put that behind an application gateway. So I've solved that a couple of times, Felix. I think that would lead to a longer, not explanation. So that's basically how I walked or find my way through that requirement. But yeah, I think that's solved, and it was already solved before dynamic modules or dynamic blocks and module support. So yeah, maybe we have to look into that in more detail to see where the problem actually is. But that would be my guidance, or my the way I would try to solve that requirement, to have a list of maybe complex variables, right? So you can create a variable of type object, and there you can provide your custom configuration per app service instance, and then iterate over the list and create the modules. So that would be my idea how to solve that.
Okay, great, thanks. We already received a thumbs up from Felix in the chat.
Oh, okay.
So
good. Yeah.
Thanks for the feedback, Felix. Okay, that was the Q&A section with all 5 questions and answers. Well, for today, the only thing left is to thank everybody for attending. From my side, Thorsten, do you have some additional words, or just?
Yeah, also from my side, thank you for joining the webinar, and I hope you enjoy the rest of the week, the month, the year, and enjoy, perhaps, or hopefully enjoy some vacation time from Christmas up until 2021. And if you have any questions, just reach out, and otherwise enjoy the rest of the time, the rest of the year, not of time. Sorry.
Okay, thanks. Before leaving, I would like to ask you if you can just leave us some feedback in the following website. That would help us to improve ourselves. So would be great. So thank you again. Have a great day. and I would join in Thorsten with my wishes for you for the rest of the year. And well, see you next time.
Bye.
Stay healthy and goodbye.